Now that you know how to calculate empirical formulas, we can move on to molecular formulas. Molecular formulas are not the simplest whole number ratio like empirical formula, but they are the actual formula of a compound. In order to find the molecular formula of a compound, we must first find the empirical formula. Once we find the empirical formula, we calculate the mass of the empirical formula, divide the molar mass given by the empirical formula in order to find the ratio, and then multiply all atoms by this ratio to obtain the molecular formula. Go ahead, write this down. However, it really has no meaning until we put it in practice. So now we're going to practice a problem once you finish. Pause now and we'll move on. Finally, let's calculate this molecular formula. A compound with an empirical formula of C3H2N is found to have a molar mass of about 310 grams per mole. What is the compound's molecular formula? Well, in this case, what we must do is to calculate the empirical formula of the compound, but this is already given. So we are going to use that formula, and it is C3H2N. We're going to calculate its empirical mass, and we are going to go ahead and take a moment to calculate its empirical mass. 3 carbons, 12 hydrogens, and 1 nitrogen. Pause. Its mass is 52.06 grams per mole. Therefore, now we're going to take the next step, refer back to your notes. We're going to take the mass given, the molar mass given, 310 grams per mole, divided by 52.06 grams per mole. This gives us 5.95. I hope you calculated it, which is about 6. This means that this formula, C3H2N, we're going to put it in parentheses, and we're going to say times everything by 6. 6 times 3, 6 times 2, 6 times 1. This is going to give us a formula equivalent to C18H12N6. Perfect. This is the molecular formula for this empirical formula. This is the actual formula of this compound. All right. Have a great evening, and we'll see you tomorrow. We'll practice a lot tomorrow. Take care. Well, since we're on the subject of molecular formulas, I'm going to tell you the formula of caffeine. Caffeine's formula is C8H10N4O2. So it contains carbon, hydrogen, nitrogen, and oxygen. It is naturally found in coffee and added to many other drinks, and naturally found also in chocolate. Its molar mass is 194.1 grams per mole. Now, caffeine is actually a white powder, and it is it's a crystal, which really has no odor. Just for comparison's sake, when you drink espresso, there's 21,202 milligrams in a cup of espresso. That's a lot of stimulant there. Sometimes the problem with coffee is that since it's a stimulant, some people feel the effect of the coffee by having a little bit of palpitations or heavy pounding of the heart, a little faster than usual. That's my problem. My speed is all that I can do is Nesquik. That's what I do in the morning, and that has a very, very small amount of caffeine. Actually, it has, I believe, 202 milligrams, something to that effect. So it's a little bit of a coffee effect, but not quite. Very, very small amount. Also, chocolate contains caffeine, and of course, all of those energy drinks, which people overdo these days. They're not very safe because they have a high content of caffeine, and some people are very sensitive to it. All right, well, there's caffeine in here as well, and just in regular coffee. This is Brazilian coffee that my husband enjoys, and he likes this strong coffee, his espresso. But I couldn't do this at all. All right, well, see you in class.